Hello, why are you in another dark hole, Simon? Welcome to my world. Welcome to top of the world. We're in another cellar, in another house, far, far, far away. This is a different kind of heating used here in the Arctic. This is a normal house, as normal as they get. Concrete cellar, wooden house, tin roof, full water central heating system. Unfortunately, this central heating system's only got water in it. It's a relatively new purchase, and given what's coming in the world that we live in with power cuts and uncertainty, and even in a normal world, these systems should have glycol in them to stop them from freezing. If the power goes down, then these houses, they're not that well insulated, will freeze up faster than you can possibly believe. And it will blow all the pipes and radiators. And. So we fill it with glycol. I don't know why this one is not filled with glycol. It's just pure water. So today we're going to fill it with glycol. This is the system we've got. Now I've already opened it up, and I opened it up yesterday to see if there was a filling loop inside here. I'll bring you guys in and you can have a look, and there is. So what I've done is, for those of you who are regulars, you will know I have an RV shower sink pump that I use to recirculate glycol and surplus water in my own system, and I can put it back into the system under pressure. I've removed that from my cellar and brought that with me today with a number of other pipes and connections so that we can connect into this filling loop and use the ethylene glycol here in the tubs and pump it straight into the machine. So I'll show you what we've got in there, and then we'll do our initial setup. Before we can put the glycol into the system, we have to drain the system. And we don't want to drain the system fully. That's going to cause all kinds of airlocks and problems and anything else. In addition to that, this is live. And the reason it's live is because it's mid-October. The temperatures are dropping rapidly. The first snow is due in just a few days. Traditionally, somewhere between the 14th and the 18th of October, the first snow comes. That snow don't always stay. It comes and it can go, but the temperatures are starting to drop. So we don't want to empty this completely. We only want to empty out 150 litres. 150 litres is what we're filling back the system, filling in the system with, trying to get a 40 to 50% mix of glycol water. That way we're good down to minus 40. That's the plan. Right, I'll bring you in and I'll show you this filling loop. So this is the system we've got. And for me, this is a good system. It's a slightly old one and it's all manual. The modern ones are really complex and you need a degree in computer science to be able to operate them. Now they should be able to set them up and then just run. Yeah, you would like to think so. Anyway, so I've opened up this front panel, and here on the inside we have a filling loop. Right, with a tap. As with every job here, right, you start with one thing and it just escalates. Are our ground drains blocked? Solid, yes. Do they drain away at all? No. Right. Do we have any more? Let's find out. Right, we can see this one's just been installed prior to the sale of the house. Does this one work? Yes. Okay. So I expect the other one is either blocked solid through dirt and rubbish, and or the old clay pipes have all shifted with the permafrost and they no longer operate. But this one seems to be operating, so we'll use this one. That looks like that might have something exceedingly heavy inside it. What am I doing? Well, it has. Is that a sensible thing to do? Well, we'll have a look under this tomorrow, and I think you'll be amazed that I've done something that stupid. There's that awful noise again. Okay, so I've reversed it now. I've drained out all the fluid, and now we're pumping in through the same port the ethylene glycol. Their pumps are quite a good rate, as we know, for a small pump. There's the pump. We know this pump, but that pumps at quite a good rate. So we'll refill the system now. We'll certainly, I've got all the radiators open upstairs, we'll certainly go into 100 litres, and then we'll start going up to the next level to get the last 50 litres in. and then we can run the pump, empty out the air and check the system. We're on our last barrel now, and I got the pressure up to 1 bar. Okay, that now means we need to go, and I've started the pump back up. Pump is running. Now we've got to go around and start letting the air out upstairs, and we'll reduce that pressure, I'm hoping, back down to nothing. Right, look, we have to go repressurise the system. Not quite zero, but anyway, right, let's carry on. We've got our pressure up to 1 bar, exactly. That way I can see exactly what's going on. I worked with this a bit now for a few hours, and I don't know why initially I was under the impression this was a rock heat boiler, furnace, heater. It's none of those. It's straightforward electric panel. Takes cold water in, puts warm water out, provides hot and cold water and central heating. Right, it's not rock heat, it's just an electric heater. Very simple. Have we got warm water? And the reason that I had to look at this, to be honest, is because something that uses rock heat takes days or even weeks to warm up. And I'd had this switched off, and of course I had drained about 50% of the water out of the system and filled it back up with glycol. And I put the pump and the heater back on whilst I'm bleeding the very top, and there was warm water coming through. And that didn't sit with me. That didn't sit with me at all. How can there possibly be warm water coming through already when I've only just filled the system with cold? Well, then I come down and look at this and looked at where the converter was from the rock heat, and there wasn't one. And then I took a closer look, and it's just an electric heater. Yeah. Anyway, she's alight and working, and got the temperature in the radiators to 40 degrees. So we can effectively now... The only trouble with turning that down, off, no I can't, I've got to leave it on for 24 hours whilst it works all the air out of the system. Although I have bled all the radiators numerous times. There is a radiator upstairs with a stuck stat. I'm just going to go and deal with that now. Is it dark in here? Yeah. Right, I can't imagine when this one was last turned on. Anyway, the stat was well and truly off. And there's warm water running through it now. Amazing things these are. They put out so much heat. So much heat. Anyway, so far we've got no leaks. Well, I think we're done down there for today. There's no heat in this room at all. No. Okay. We're all good with no issues. Right, this is the last radiator I've had a problem with. So this is a mechanical thermostat. This goes on the end like that, and as you screw this in or out, it pushes this in or out, which controls the valve in there, and it was stuck. So what you do is you get a pair of pliers and you pull it out. You can see how that pushes in and out a little bit. It's just free flowing at the moment. If you push it, you can push it all the way in, it shut the valve. You get it all the way out, it opens the valve. So what I did was pushed it in and out repeatedly with a pair of pliers until this valve broke open, and now I can feel warm water flowing. So that's the last of the issues we've got, and I think we're complete. I can tell you by the colour of the water coming out, I don't need to do a glycol test, but I will do one in the morning. So I'll leave it running now with the heat on for 24 hours, come back in the morning, take a sample out, test it, make sure I'm at the right level. I've also turned the hot water on because the hot water doesn't work for whatever reason. So I've now turned that on. Well, I know why it doesn't work because it was turned off. I've turned that on so I can test the hot water heater working. Then I can turn that off, and then we can crank it down, and yeah, that's that particular job finished. There we go, car full of empty barrels. Finished. So what did that take? Where is it now? 1300. 4.5, 5 hours. That's another critical job completed just before winter. That'll be safe now, whatever happens, whether the power goes down or not. The bulk of that plumbing in that building is going to be safe and secure. That's that. Thanks for joining me. We'll catch you on the next one. Bye for now.